Why do magnets have north and south poles? Hello, everyone. Today, we'll be discussing the fascinating topic of why do magnets have north and south poles. To begin with, magnets are objects that generate a magnetic field, which is an invisible force that attracts or repels certain materials, such as iron, nickel, and cobalt. The word magnet comes from the Greek word magnetis, meaning steel that attracts iron. Magnets are one of the deepest mysteries of physics, and even though humans have used them for thousands of years, scientists are still learning new things about how they work. Have you ever wondered what would happen if you saw a magnet in half? You might think you would end up with two pieces of non-magnetic metal, like cutting an apple, but that's not what happens. No matter how many times you cut a magnet, each piece will still be magnetic and will have a north and south pole. These smaller magnets will attract or repel each other just like a large magnet. This strange behavior makes magnets an indispensable tool in human life. You can use them to decorate your refrigerator or use them to explore inside the human body. What is the mysterious power of magnets that allows them to do this? To answer this question, we must first understand what magnets are made of. All matter, including magnets, is made up of atoms. In each atom, the nucleus is surrounded by one or more electrons with a negative charge. Each of these electrons creates its own tiny magnetic field, which scientists call spin. If enough of these tiny magnetic fields point in the same direction, the material itself will become magnetic. The spin of an electron is an abstract concept. Technically, no one has ever seen the spin of an electron. It is too small to be seen under a microscope. But physicists know that electrons have a magnetic field because they have measured it. One way this field is created is that the electrons are spinning. When possible, electrons pair up so that their spins cancel each other out, making the total magnetism of the atom equal to zero. But in some elements, such as iron, this does not happen. The number of electrons and how they are positioned around the nucleus can lead to each iron atom having one unpaired electron, creating a small magnetic field. In unmagnetized materials, these individual magnetic fields point in different random directions. In this state, they mostly cancel each other out, so the material is generally not magnetic. But under the right conditions, the tiny subatomic magnetic fields can align and point in the same direction. These tiny magnetic fields combine to create a larger magnetic field, which is why iron can become a magnet. Many magnets used in everyday life, such as refrigerator magnets, are permanent magnets. In these materials, the magnetic fields of many atoms in the material have been permanently linked by some external force, as if they were placed in a stronger magnetic field. Usually, the stronger magnetic field is created by electricity. Electricity and magnetism are fundamentally related because a magnetic field is created by the movement of electric charges. That's why spinning electrons have a magnetic field, but scientists can also use electricity to create very strong magnets. Running enough current through a coil of wire will create a very strong magnetic field that exists as long as the current flows. These electromagnets are often used in physics research. They are also used in medical devices such as magnetic resonance imaging (MRI). The Earth also has its own magnetic field. This is how a compass works. Scientists define the north pole of a magnet as the end that would point towards the Earth's north pole if the magnet were free to rotate. But technically, this means that the Earth's north magnetic pole is actually a south magnetic pole, because opposite poles attract each other. Explains Gregory Scott Bobinger, director of the National High Magnetic Field Laboratory in Tallahassee, Florida, and now professor of physics at Florida State University. In physics convention, magnetic field lines run out of the north pole of a magnet and enter its south pole, forming a closed loop. You can observe this phenomenon by performing a simple experiment using some small iron filings and a magnet. Place the magnet on a piece of paper and sprinkle some iron filings on the paper. You will see that the iron filings are arranged along the magnetic field lines, forming a pattern. This is a visualization of the magnetism of the magnet. Physicists have also discovered other arrangements of magnetic poles, including quadrupoles, in which a combination of north and south magnetic poles are arranged in a square. But there is one goal that is still elusive. No one has yet discovered a magnetic monopole. Electrons and protons are electric monopoles, and they both carry a positive or negative charge. But electrons and other particles have two magnetic poles. Since they are elementary particles, they cannot be divided any further. The difference between how particles behave electrically and magnetically has intrigued many physicists. Its discovery would challenge the laws of physics as we currently understand them. Magnets are one of the deepest mysteries of physics, and even though humans have used them for thousands of years, scientists are still learning new things about how they work. Perhaps one day we will discover all their secrets. Once again, thank you so much for watching this video, and I'll see you in the next one. Take care, and have a fantastic day.